Good evening, dear students. For the electronic configuration, SPD, and the orbital notation, many students have confusion. Ndagira ngo ngusuzume munyeshuri mu biruhuko, nawe wenda waba utumva n'ururimi rw'icyongereza neza. Ibibazo bisigaye ari multiple choice, ni ukuvuga ngo ugomba kumva ibintu neza cyane atari kubifata mu mutwe gusa, ahubwo ukamenya n'aho biturutse. Niyo mpamvu rero ngiye kukwereka neza ukuntu ushobora gukora electronic configuration ya element twita transition ziri hejuru ya 20. Ni ukuvuga ngo duhereye ku yo twita scandium tukagera kuri zinc. Hano hagati bikorwa kimwe, ariko harimo ebyiri, iyo twita chromium n'iyo twita zinc. Izo ngizo zifite umwihariko wa. Now I'm going to show you how to deal with the electronic configuration of D block element and including transition metals first series. I would like to show you the orbital notation. It means that electrons are in boxes, and from scandium to zinc. Here element number, it is scandium. Scandium is the element Z is equal to 21. And here I start by showing you the first box. Here, by using condensed electronic configuration, we start by configuration of argon. Argon is 18. Then for scandium we have to add 3 electrons. 3 electrons. Here, the next orbital will be 3d. Then the orbital at the outermost shell is 4s. But here, because we start what we call transition, we have to start by 4s. 4s, it means that even though it is number 4, it comes before 3. When the orbital of the higher energy level is placed before the orbital from the subshell with low energy level, this is the transition, because the low number is placed after the high number. For this reason, 3D in what we call quantum numbers, we know that S has 1 orbital, but D has 5. 2, 3, 4, and 5. You know that every orbital must have 2 electrons. Here for 4s, we start by putting 1 and 2. 1 and 2. Electron, the next electron will be on 3d. 4s will have 2, while 3d will have 5. Here 2 plus, it will have 1. It means 2 plus 1 will have 3 electrons. Those 3 electrons that we have here, plus 18 of the configuration of argon, the total will give 21. We can continue to add the next will be titanium. Z is equal to 22. We'll start by configuration of argon as we did for scandium. Here we start with 4s. Maximum is 2 electron. One electron is upright, another is inverted, or it is placed downward. Go to subshell or sub-energy level 3D. Because here we have 1, the next we'll have 2. In order to have 22, I will put 2. 1, 2, 3. 1, 2, 3, 4. And the orbital must be 5. Here I put 1. I cannot put another here because no orbital can have more than 2 electrons, but you cannot pair without finishing to place the single electron. The reason why the next will be here and upright. When upright electrons are finished, we can start to pair with inverted or downward electrons. Here you find that it is 22. The next is vanadium. Z is equal to 23. Z is equal to 23. We use the configuration of argon as well. But I wanted to explain you that to use the condensed when you are in assessment, for example, you are doing examination or a quiz, it is not good. You have to display even the configuration of argon. It is 1s2, 2s2, 2p6, 3s2, 3p6, equal to 18. Here for transition, in order to save the time, this notation is called condensed electronic configuration by using configuration of the nearest noble gas. Here, when you are doing exercises, because you want to save the time, you can use this. Here, I can put 2 electrons, 4s2, but here the remaining are 3. 1, 2, 3, 4, 5. You know that this is the 3D must have 5 boxes or 5 electrons. 1, 2, 3, 4, 5. Then I have to put 3 electrons. 1, 2, 3. This is, it means that this is vanadium. You find that for those those elements, electron configuration, find that 3D will continue to have some vacant orbitals. Here, I encourage you to continue to see, because I want to finish here by showing at least 5 transition methods. We'll continue to tomorrow. Here I have chromium. I have shown you that chromium is an exception because here configuration of argon, I will have 4s2. Here I may have 4s2. 1, 2, 3, 4. 1, 2, 3, 4, 5. 3D. Here I can put 2, and here I can put 4 if I respect what I did for others. It means that here I can put 1 here, but instead of putting the other one, I put 1, 2, 3, 4. Then instead of putting electron here, which is downward, the electron which must be here can support 3D in order to be stable. Because to be stable is to have 5 electrons, is to have every orbital has 1 electron. It means that this is stable. Electron which was here has helped 3D to be stable. Here, if we transfer electron here, we can cause the problem here of not having more stable, and here also it cannot be more stable because here we will continue to have the vacant orbital. But when we return back to manganese, where Z is equal to 25 argon, here no problem, I continue to have 2 because the remaining 5 exactly 1, 2, 3, 4, 5 will give us the stability of having a single electron in every box. Thank you very much. You find that this chromium has an exception of having 1 electron here, and here also it is exception because electron which must be here is placed here to allow 3D to be stable. Is here you have to understand more the exception, because if a person wants to assess, the first thing to be assessed is to see whether you have understood the exceptions. My dear student, this is the coach who is coaching online. My name is Epimake Rudakubana. Ndagira nkubwire ngo hari igihe byakugora kubona umuntu uza kwigishiriza mu rugo, ariko ubu umukoci arahari. Uko byaboneka kose aka gasomo urakumvise, uko tugenda tubyara ariko twagera hano kuri chromium twabona iyo hasaguka akazu kamwe ushobora kwimura kuri 4s electron imwe ukayizana kugira ngo wuzuze utuzu twose. Kuko iyo twuzuye buri kazu karimo electron imwe, icyo gihe tuvuga ko ibintu biri stable. Ariko iyo uyimubona wakimura n'ubundi bigakomeza kuba vacant, ni ukuvuga n'ubundi ntiwirirwa wimura kuko stability waba ushaka n'ubundi ntiyabishoboka, hose habakomeza kuba ikibazo. Rero ubwo chromium is an exception. Ejo bundi bakubaza ikibazo rero bakaguha configuration element zose bakazifiringa kimwe, uzahita uvuga uti iki bintu ikitakoze neza ni iki cya chromium, hanyuma iyo nyuguti izaba ihari uyisayikore uvuga uti bashobora kuvuga bati among the electronic configuration what is the configuration which is wrong, hanyuma bagahita hano bakubitamo 2 tune dusigaye bakadushyiramo nk'uko babikora ku bandi. Ubwo rero nshuti yanjye munyeshuri, rwose uzitonde umenye ko ibyo bintu atari byo, ahubwo ko ari agatego baguteze, nta kundi. Burya rero niryo banga ukunda kubona abanyeshuri nyine batsinda ukayoberwa aho babikura. N'utu tuntu tw'udutego baba baragiye bahura n'umuntu uzi kudutegura neza. Rero nawe aka kantu uhite ugafata. Thank you very much. We'll continue next by drawing electronic configuration, orbital notation. Orbital notation means electrons are in those boxes. Boxes are the shape of the drawing of orbitals. Continue with manganese. No, this is manganese. We'll continue with iron, cobalt, nickel, copper, and zinc. We'll see how properties of those elements are almost the same except the first and the last, means scandium and zinc. Thank you very much indeed. Don't forget to click subscribe. Abasanzwe mukurikira iyi channel mu rurimi rw'ikinyarwanda, mwabona ko hari igihe hajyaga hajyaho ibiganiro biri mu buryo bw'iyobokamana, ariko ubu ntabwo byabaye bihagaze kubera ko ku bantu b'abavugabutumwa hari umurongo urimo uratangwa mushyashya. Mwihangane, nabyo bizongera bigarukeho ariko mu gihe kizaba ari ngombwa. Thank you very much. Mukomeze mugire ibiruhuko byiza, hanyuma mukomeza mwiga chemistry mwigira mu rugo.